Numbers are the foundation of our world. They help us measure distance, time, money, and even the stars in the sky. For most of human history, numbers were seen as quantities that you could count. Things you could actually hold in your hand. 1 apple, 2 apples, 3 apples. But what about less than nothing? What about owing 3 apples? For a long time, this idea felt absurd, even impossible. Yet today, negative numbers are a part of our everyday lives. From bank accounts to temperatures, from science to sports, negatives shape the way we understand the world. But how did this strange invention come about? That's the story we're going to uncover. The long, fascinating journey of negative numbers. A negative number is simply a number that's less than 0. It's the opposite of a positive number. If positive numbers represent what you have, negative numbers represent what you owe. If positive 3 means $3 in your wallet, negative 3 means you owe someone $3. They're written with a little minus sign in front, like 3 or 10. And just like positive numbers, they stretch on forever. You can keep counting down infinitely. 0 sits in the middle. Everything to the right is positive. Everything to the left is negative. It's a simple picture, but it wasn't always simple for people to accept. Today, negatives feel natural. If the temperature falls below freezing, we say it's -5 degrees. If your bank account dips into overdraft, you see a negative balance. In golf, a negative score means you're doing well. In science, an electron has a negative charge. Negatives are everywhere. But if we look back in time, this wasn't the case. For many ancient mathematicians, the idea of a number below 0 made no sense. How can you have less than nothing? And that's where our story begins. Over 2,000 years ago, in ancient China, mathematicians were already using negative numbers. In a classic text called The 9 Chapters on the Mathematical Art, scholars used counting rods on a board to solve equations. Red rods represented positive numbers, black rods represented negative numbers. With this system, they could calculate gains and losses, assets and debts. By the 3rd century, the mathematician Liu Hui was explaining rules that we still use today. He described how 2 negatives make a positive, how subtracting a negative is the same as adding, and how negatives balance positives. These rules weren't strange to the Chinese. They made sense in the context of yin and yang, the philosophy of opposites. Gains and losses, hot and cold, positive and negative. Everything had a natural duality. In China, negatives weren't absurd. They were simply part of the balance of the universe. Around the 7th century in India, negatives took on a new life. The mathematician Brahmagupta gave them a clear and powerful interpretation. He described positive numbers as fortunes and negative numbers as debts. It was an elegant way of explaining them. 10 coins in your hand meant +10. Owing 10 coins meant 10. Brahmagupta didn't just describe them. He wrote out precise rules. A debt plus a debt is a bigger debt. A fortune plus a fortune is a bigger fortune. A debt minus a debt is their difference. And a debt multiplied by a debt is a fortune. In other words, negative times negative equals positive. This was revolutionary. With these rules, Indian mathematicians could solve equations more generally. They used negatives in formulas, including versions of the quadratic formula, centuries before they were formalized in Europe. To them, negatives were not a curiosity. They were practical tools, essential for understanding balance in mathematics. From India, these ideas traveled west into the Islamic world during the Golden Age of Islamic scholarship. By the 9th century, mathematicians were studying algebra in detail. Al-Khwarizmi, known as the father of algebra, did not use negatives directly. He worked around them. But soon, others like Abu Kamil and Al-Karaji began experimenting with negative coefficients in their equations. They thought about debts and deficits as negative values. Scholars like Abu al-Wafa explained negatives as debts subtracted from fortunes. These mathematicians didn't always embrace negatives fully, but they acknowledged their usefulness in solving problems. Through the Islamic world, knowledge of negatives slowly spread westward toward Europe. And this is where the story gets complicated. Europe resisted negative numbers for centuries. For the ancient Greeks, numbers were tied to geometry and physical reality. To them, mathematics described lengths, areas, and volumes. You could have 3 lengths of rope, but you couldn't have negative rope. You could have 4 apples, but negative apples made no sense. The mathematician Diophantus in the 3rd century encountered negatives when solving equations. He dismissed them as false, as meaningless answers. This attitude lingered for more than 1,000 years. Even as late as the Renaissance, many European mathematicians considered negatives absurd. Nicolas Fouquet in the 15th century used them but called them absurd numbers. Michael Stifel in the 16th century also described them as nonsensical. It was Girolamo Cardano, in his 1545 book Ars Magna, who began to give negatives a real place in algebra. Even then, he treated them cautiously, admitting they were strange but useful. Later, great thinkers like Leibniz still struggled with the concept. He admitted negatives worked in calculations but described them as leading to absurd conclusions. Europe used negatives grudgingly, always with suspicion. It took until the 18th and 19th centuries for them to finally become fully accepted. So why did negatives eventually win? Because they worked. Let's take a closer look at their arithmetic. Imagine a number line with 0 in the center. Move right for positives, left for negatives. Adding a negative moves you left. Subtracting a negative moves you right. Multiplying is where the rules feel strange. A positive times a positive is positive. A positive times a negative is negative. But a negative times a negative, that equals positive. Why? One way to see it is through patterns. 2 times 3 is 6. 1 times 3 is 3. 0 times 3 is 0. Negative 1 times 3 is negative 3. Negative 2 times 3 is negative 6. Follow the pattern, and negative times negative must equal positive. Another way to see it, if losing money is bad, then losing a debt is good. Negatives cancel each other out. These consistent rules made mathematics stronger and more complete. Once negatives were accepted, they became useful everywhere. In daily life, we see them all the time. A football team's goal difference might be negative. A golfer's score below par is negative. In racing, negative times represent how much faster a lap is compared to a standard. In science, negatives are fundamental. Temperatures drop below 0. Elevations fall below sea level. The Dead Sea, for example, lies hundreds of meters below 0 elevation. Electricity relies on negative charges. Chemistry deals with negative ions. Physics uses negatives to describe direction, velocity, acceleration, even energy. In finance, negatives dominate. Bank overdrafts, losses in the stock market, government deficits, all are described with negative numbers. In technology, negatives sneak into design. Elevators have negative floors below ground. Video games use negatives to track lost points or health. Even music players once displayed negative numbers to show time remaining. What was once absurd is now essential, but the importance of negatives goes deeper than just usefulness. They represent a turning point in mathematical thinking. With negatives, numbers were no longer tied only to physical objects you could count. They became abstract concepts that could represent ideas, debts, losses, opposites. This opened the door to even stranger mathematical inventions. Once you accept negative numbers, it's only a small step to imaginary numbers, complex numbers, and beyond. Negatives taught humanity that mathematics isn't limited to what exists in the physical world. It's about consistency, possibility, and abstraction. The journey of negative numbers is a story of human imagination. In ancient China, they were rods on a counting board. In India, they were fortunes and debts. In the Islamic world, they were debts and deficits in algebra. In Europe, they were resisted, mocked, and called absurd, until eventually, they were embraced. Today, we use them without a second thought. But once, they were controversial, mysterious, even feared. And yet, by daring to accept what seemed impossible, mathematicians discovered one of the most powerful tools in mathematics. So the next time you see a minus sign in front of a number, whether it's on a thermometer, a bank account, or a math problem, remember the long journey it took to get there. That tiny sign carries thousands of years of history. It reminds us that sometimes, to move forward, humanity first has to go below 0.